Welcome to this session. Uh, we have already studied DC machines so far. I will be taking up transformers. So as we have studied three different types of machines, so we have studied there's a motor, there's a generator, and the third type of machine that we have is a transformer. While motor and generator, they are actually used for uh, conversion of energy. A motor converts electrical energy into mechanical energy, and a generator converts uh, mechanical energy into electrical energy. The transformer does not convert energy, rather, it transfers energy. So you can have a circuit, so you need to have at least two circuits. So the side that is actually excited, and this excitation will be using an AC voltage source. So this circuit will be known as the primary side, or the primary circuit, and the second circuit that we have on this side, which actually receives the energy, it is known as the secondary side or the secondary circuit. Fine. We have two electrical circuits. We have at least two electrical circuits. So the primary electrical circuit will transfer electrical energy to the secondary side of the transformer. Fine. Important thing to note here is that this is only possible with uh, the voltage being AC in nature. Fine, you need to excite it using uh, alternating current, alternating voltage. Uh, DC voltage are not able to exhibit this phenomenon. Uh, we'll actually be studying more about this in the principle of operation of the transformer. So, in short, what a transformer does is it transfers electrical energy from one electrical circuit to another electrical circuit. The electrical circuit that is actually supplying the electrical energy is known as the primary side. The electrical circuit that is actually receiving the electrical energy is known as the secondary side. Now, as I said to you that there needs to be at least two electrical circuits. You can have more than two electrical circuits. On the primary side, you can have one coil. On the secondary side, you can have number of electrical circuits. So each of these electrical circuits are actually electrically isolated from each other. By electrical isolation, we mean that there is no physical connection, there is no electrical wire connecting the primary and the secondary side, or the secondary and the secondary with each other. Fine. So a transformer simply transfers electrical energy from one side to another, from one electrical circuit to another electrical circuit via magnetic means, while there being no electrical connection between the primary side and the secondary side. Right? So normally there is no electrical connection between the primary side and the secondary side, except in case of auto transformers, where the primary side and the secondary side, they are not electrically isolated from each other, but there is an electrical connection between the primary and the secondary side. So this is the basics of your transformer. What actually a transformer does, it transfers electrical energy from the primary circuit to the secondary circuit via magnetic means, while ensuring that your uh, primary side and the secondary side are isolated from each other. Regarding why do we use transformers, there are a number of reasons for using transformers. The primary objective of a transformer is to step up or step down voltage oblique current. So what happens in case of your transformer is that the primary side and the secondary side are actually transferring electrical energy but at different voltage levels. So if the voltage level on this primary side is 100 volts, on the secondary side the voltage level can be 150, 125, or it can be less, it can be 75 volts, it can be 80 volts, so on. So the transfer of electrical energy takes place with change in voltage, but the power in the two sides remains constant. Why? Power being constant. So if your power is constant, that means your input power in the circuit is actually equal to the output power. So if input power is given by Vi, let's assume that the current flowing in the circuit is 1 amperes. So the power in the input circuitry, that is the primary side, is 100 volts into 1 amperes, that is 100 watts. So on the secondary side, it's necessary that the current that will be flowing in the circuit is such that the output power will always be equal to 100 watts. So for example, if the voltage is 150 volts, your current on the secondary side will be 100 divided by 150. That's roughly point. That's actually 0.75. Uh, that's 0.66 amperes. So what you are seeing, that is your voltage on the primary side is 100 volts. Your voltage on the secondary side is 150 volts. But if your current on the primary side is 1 amperes, your current on the secondary side will be 0.67 amperes. That means if P in is equal to P out, that means Vi, V primary and I primary has to be equal to V secondary into I secondary. So therefore if Vp Ps is greater than Vp, it will ensure that Is will be less than I. So while your voltage is being stepped up, your current is being stepped down. Or on the second, or contrary to this, if your voltage on the secondary side is less than Vp, then for maintaining the same amount of power, Is has to be greater than the primary current. So secondary current has to be greater than the primary current. So if your voltage is stepped down, your current has to step up. This is your primary purpose of using a, a transformer, that is for stepping up voltage or stepping down voltage, or relatively what will happen is respectively what will happen is that V IP, the current will be stepped down or current will be stepped up. Now where do we use this? We use this either in power system networks, or we use this residentially. We are discussing the whys, and as I was telling you, uh, it will be for voltage oblique current, step up, step down. And where do we use this? In the power system network or residentially. So you may have seen what exactly we do in power system networks is that at the generating station, the voltage is generated at 11 kVs, but for reducing the I square R losses in the system, to reduce the I square R losses, we step up this voltage, and we can step it up there are a number of voltage levels to which we step up: 132, 400, 440, 700, 1100 kV, so on. Fine. We can step up this voltage. Now, why we step up this voltage? Because if we step up the voltage, the current will decrease. If the current decreases, I square R losses in the system will decrease. We can then transmit this voltage over a long distance, and at the distribution stations, at the distribution side, because the consumers cannot directly consume 1100 kVs, so using a series of transformers, substations, distribution transformers, extra, this voltage is subsequently reduced from 1100 volts to 230 volts, 230 oblique 440 volts, that goes to residential purposes. So this is what we do in case of power system networks. We increase the voltage. The funda of increasing the stepping up the voltage is to transmit the voltage over long distances. By reducing the I square R losses, we need to step up the voltage. To step down the current, I square R losses are reduced, and we can transmit the voltage over long range, over thousands of kilometers. Fine. So using a series of transformers from 11 kVs to 230 volts, that's actually available to a consumer, or if it's going to industrial purposes, they directly require 11 kV volts. So for them it will be reduced to 11 kVs. Even specialized lines, like in case of so if you may have if you get a chance to visit the substation of your campus, NIT Srinagar, you will see that the voltage that's actually received is 11 kVs, and using the local distribution transformers, we are able to reduce that voltage to 440 oblique 230 volts for single phase and three phase purposes. So this is your power system network. Similarly, in residential purposes, what we do is we use transformers. Residentially, the voltage that your equipments require is 230 volts, but the available voltage is most often less than that. It will be around 200 volts, 150 volts, 100 volts, and even in some cases, in extreme cases, the voltage is as low as 50 volts, even in steels. So this voltage will actually cause damage to the equipments being used in this in your household. So what we do is we uh, step up the voltage that's actually available uh, that's actually being available to the consumer using step up transformers, using simple transformers that are available at home. So this is your primary purpose of using a transformer: voltage oblique current, stepping up or stepping down. And based upon this, I'm actually going to write the types of transformers as well on this side. Based upon this, the transformers are classified as step up transformer or step down transformer. So a step up transformer will step up your voltage, and uh, what will happen subsequently, the current will be stepped down, while as your step down transformer, it will step down your voltage, and the result is that the current will be stepped up. Second purpose of using a transformer is for measurement purposes. So what does this mean? Again, as you can see, the transmission voltage is as high as 1100 kVs. The generating voltage is 11 kVs. So these are actually uh, you may have generation even at 6.6 kVs, and there will be again other intermediate voltage levels that are actually used: 33 kVs, 132 kVs, 440 kVs, 700 kVs, 1100 kVs. So there are a number of voltage levels that have actually become an industry standard for uh, for use. Now this voltage cannot be directly measured. You cannot measure 1100 kV directly. So for that you need to actually reduce this voltage. And if you know the transformation ratio of your transformer, say for example your transmission voltage is 1100 kVs, using a step down transformer you are reducing it to say for example 1000 volts. So you know the transformation ratio here is 11,000 divided by 1000 volts. So accordingly whatever will be the reading, you will multiply it by 11,000 divided by 1000. That will actually give you the actual value of voltage. So the case here is that you cannot measure 1100 kV directly. You need to reduce it first, then you can use voltmeters, ammeters or other measuring devices to measure voltage extra. So for both voltage as well as current measurement in transmission lines in power system networks, we require specialized transformers, and these transformers are known as potential transformers and current transformers. So potential transformer is a step down transformer. It steps down your voltage so that it becomes possible for us to measure the voltage. Current transformers, they are step up transformers. That means they actually reduce the current so that the current on the secondary side is measurable for the user. So for measurement purposes, instrumentation transformers are used, and therefore the types of instrumentation transformers are potential transformer and current transformer. So collectively they are known as instrumentation transformers. Third purpose of using a transformer is isolation. Uh, what happens is you may have some circuitry, say for example this is mostly used in electronic circuits. So you may have on this side you may have a signal generator here, you may have some other systems, diodes, capacitors, inductors, extra. Fine. Resistances, some ICs on the circuit, and you have another part of the circuit where you have a oscilloscope where actually you measure the waveforms. You may have again some ICs, resistance, capacitance. So in electronic circuits what happens is that the ground potential we actually assume, we hope that it is actually 0 volts, but the thing is that the ground potential will not always be 0 volts. Say for example on this, for this circuitry the ground potential is say for example 0.1 volts and the ground potential here is 0 volts. So the potential difference between these two circuits is 0.1 volts. Since 0, and if the resistance is say for example in uh, milliohms, so you can assume, you can understand what will be the value of current that will be created because of the potential difference between the grounds of two circuits. So uh, this should not happen. Now what we can do to prevent current to flow in this circuit is we need to isolate the grounds on the two circuit sides. Once we isolate the ground, there will not be any potential difference. So since there is no electrical connection, no current will flow from this part of the circuit to this part of the circuit. So isolation transformers, the purpose of using isolation transformers is to simply isolate one circuit from another circuit, so that this can again be for different reasons. The most important reasons that I have explained here is for simply electrically isolating them so that there is no circulating current caused because of ground potential. So accordingly the transformer type that we have here is, it is known, it goes by the name isolation transformer. Fine. You may also hear sometimes pulse transformer. So it can also be used for simple isolation purposes. Most often the isolation transformer is 1:1 transformer. That means whatever is the voltage input on one side will be the voltage output on another side. Its purpose is not to step up or step down the voltage. The purpose is simply to isolate the two circuits. So isolation simply means there will be no electrical connection, no physical wire being present between one circuit and another circuit. There is no connection. Magnetically they will transfer energy, but electrically they are isolated from each other. So this is actually electrical isolation. Magnetically they are still coupled. So these are three important why we use transformers in a power system network for voltage, current oblique step up, step down for measurement purposes, for electrical isolation. For fourth, we can have different other. You can actually say depending upon the type of transformers, there are certain other type transformers that we will be studying. One will be auto transformers. Fine. So you may also come across the word. Uh, we may come across the word auto transformer. So auto transformer, what auto transformer does is it is not actually uh, required for it. There will be no electrical isolation between the primary and the secondary in this case. It will actually be required for minor voltage variations, minor voltage compensation, we can rather say. What happens is that there may be devices where you require 230 volts, but you are getting 210, 220 volts. So there we actually use auto transformers. So it does not have to do much of a job. It has to improve the voltage from 200 to 230 volts. But the fact here is that the power there will be as compared to the normal transformer, the power rating of this device is uh, very high. We will be actually studying that. Auto transformer they are required where you require very minor amount of variation between the primary and the secondary voltage sides. There from 200 to 230 volts, 210 to 230 volts. These are small changes that we actually require. We do not need transformers for such purposes. We can use auto transformers. The auto transformers, the feature is that the primary and the secondary side, they are not electrically isolated. They share the same winding, and because they share the same winding, uh, the electrical cost, the cost of the winding actually reduces. So we, since we are actually in require, the purpose of building such transformers is for very small compensation of voltage. So we do not want this system to be costly. So we share the windings and auto transformers are the name. Besides this, there are one more type of transformers that you will come across. You will come across the words power transformer and distribution transformer. So power transformer is actually where your your power levels very high as said in already in case of power system networks. This transformer which actually steps up your voltage from 11 kV to 132 kV, 1100 kV, so on. So these will be actually power transformers. The power rating of such machines is very high, and similarly this transformer that will actually reduce this voltage from 1100 to 11 kV back or 33 kV, whatever. This will again be a power transformer. The power rating of this machine, of this transformer, is high. Power rating is high, so it can be greater than 200 MVAs. While as a distribution transformer, that's actually locally that you can actually find locally outside your colony, your locality, that actually reduces the voltage from 11 kV to 440 volts or 230 volts. Fine. So those are distribution transformers. Their power rating is not as high as the power transformers. So these are why we use the transformers, and based upon the whys we have actually also divided the transformers into 5 different categories. You have the step up or step down transformer, you have the potential transformer and the current transformer. You have thirdly the isolation transformer. You have fourthly the auto transformers. Fifthly, you will come across the words power transformer and distribution transformer. And why we require these transformers? They can be used for voltage oblique current stepping up or stepping down. They can be used for measurement purposes. They can be used for electrical isolation or for minor voltage compensation, minor voltage stabilization. You will require something like auto transformer. So that's all for today. In the next session, we'll actually study the construction of the transformer and the principle of operation.